Let's first find what is dy dx. So from here, dy dx is differentiating it is 0, then differentiating this is negative 3. Let's bring it forward. So this 2x plus 1, 3 minus 1 is 2. Differentiating this using chain rule, this is 2. So what we have is a minus 6 of 2x plus 1 to the power of 2. And since we are talking about stationary point, we will let dy dx be equal to 0, which means that it is going to be this negative 6 of 2x plus 1 square is equal to 0, which means that 2x plus 1 got to be equal to 0 and x is minus half. And since we get only one value for x, which means that there is going to be only one stationary point, and what we need to do next is to prove that this particular stationary point here is a point of inflection. So for point of inflection, let's make use of the first derivative test. So we will construct a table, and in this table we will be looking at x, which is going to take up a value of minus half. We will be looking at dy dx, which is going to be 0, and we will be looking at the shape of the graph of y, and when dy dx is 0, that means it is experiencing a stationary point, so the tangent is going to be horizontal, the gradient is going to be something that is like this. So we will look at another value which is slightly on the left hand side of minus half, so it will be minus half. Slightly to the left hand side is negative, so we'll pick a value that is like, for example, negative half minus 0.1. Subbing into the expression of this, it will give us a negative value. This tells us that the gradient is going to be something that is like this, and we will now pick a value that is slightly more than negative half. So for example, negative half plus 0.1, and taking that value, subbing back into dy dx should give me a dy dx that is also negative, which means that the gradient is going to be negative. So the graph is going to have a curve that is curving this way, the graph of y is curving this way, and that is why we have a stationary point of inflection.